Hi Math 30-1s. Continuing on today with trig functions and graphs, what we're going to be doing today is determining angle measure from a trig ratio. So again, what we want to remember, okay, is that when we are discussing the word ratio, okay, it is a comparison of two things, okay? So when we are talking about sine, the sine ratio, we are comparing the opposite side to the hypotenuse. When we are discussing a cosine ratio, we're comparing an adjacent side of a triangle to the hypotenuse. And we are talking about tangent, we are comparing an opposite side of a right angle triangle to the adjacent side of a right angle triangle. Now, the key thing there that I was saying is that when I am discussing those ratios, okay, I'm talking about sides in a right angle triangle, which means that I need to be having as a reference angle an acute angle, an angle between 0 and 90 degrees. So what happens is this, is that when we are given a rotation angle that is greater than 90 degrees, we must use the reference angle to determine the sine, cosine, and tangent of that larger obtuse rotation angle, okay? And you're gonna see how that works today as we go through these steps. Now, in a lot of these sections, they're going to say, here's step 1, here's step 2, here's step 3, and I will discuss those with you. But a lot of times I will just highlight the key things in those steps, and then I'll explain those steps to you as I work through the problems, okay? So again, any questions at any point, send me questions through email, and I will respond as quickly as I can. So just as a review, it says angle measure in degrees from primary ratios. In previous courses, we used the concepts of a reference angle and the sine of a trig ratio to determine angle measures in degrees given a sine, cosine, or tangent ratio. So again, in Math 10, Math 20, if you were given the ratio, you'd go second function sine or second function cosine or second function tangent, okay, of the ratio you were given, and you would basically be determining the angle, okay? Today we're going to do a very similar thing, but you'll see that the value of those ratios is sometimes negative, sometimes it is positive, okay? And when we are discussing that, okay, what we are focusing on when we're given a ratio and we're looking at whether that ratio is positive or negative is our cast rule, okay, that we studied a few lessons ago. Okay, so we want to know in which quadrants our ratio that we are dealing with is positive and where it is negative. Now, from that, what we also have to always be very cognizant of in these questions is the domain, okay? The domain is sometimes very restricted, okay? So you'll see here, for an example, that I'm highlighting in red, they're talking about theta, the angle I'm looking for being between 0 degrees and 180 degrees. Well, that means to me that my solutions can only lie in quadrants 1 and 2. Okay, because those are the angles where rotation is between 0 and 180 degrees. If I look at the second one, here's a very restricted domain, 90 degrees to 180. Well, 90 to 180 would only be in quadrant 2. Okay, so you always really want to pay attention to what those domains are, highlight them, put stars beside them, whatever you do to make sure you know that your solutions could be very restricted based on the domain that they give you in the question. And again, you'll see that today. I will make sure that you notice that, and we make a point of that when we're solving the questions or the simple equations we are given. Okay, so right into question 1, it says, complete the following to solve cos of theta equals negative 0.5. Okay, this time my domain is 0 to 360. Okay, degrees. So again, I'm in degrees, not radians. This means I'm looking in all 4 quadrants, right? 0 degrees all the way to 360 means I can look in quadrants 1, 2, 3, and 4. Okay. Theta in a question like this is just basically kind of like your variable. It's your unknown angle. It's what you're solving for. You want to know what theta is. So sometimes they'll use a capital letter like A or R. Same thing as theta. Okay, we're looking for what the value of that angle is. Okay, here are the other important things. We are dealing with cosine, okay, and the ratio is negative. So the first step is you say to yourself, okay, where is cosine negative? So you think back to your cast rule, okay, and you go, well, I know cosine is positive in quadrant 4 because that's where the C is, and I know in quadrant 1 everything is positive. So therefore, that means cosine is going to be negative in quadrants 2 and 3. So that's where I am looking for my rotation angles, which is theta in this case. So what I do at this point is the following. I make sure my calculator is in degree mode because in this question, we are discussing things in degrees. I know that because of the domain, 0 degrees to 360 degrees. So at this point, I'm going to find my reference angle. So what I do is I go second function cosine, now listen carefully, of 0.5. Not negative 0.5. That negative in front of the 0.5 only indicates to me which quadrants I'm looking for my solutions in, okay? So extremely important what I just said. The negative sign only indicates to me which quadrants I'm looking in. When I determine the reference angle, I get rid of that negative, or I use the absolute value of that value that's given in the question. So I go second function cosine of 0.5. Now when you do that, you will see that you get 60 degrees. Now, obviously 60 degrees, okay, that's in quadrant 1, but that is what my reference angle is, and that's obviously why I wrote it there where it says reference angle. So that's my reference angle. So what I do is I go into the two quadrants, 2 and 3, and I determine the rotation angles, which in this case are my values for theta. So in quadrant 2, we're going to go 180 degrees minus the reference angle of 60 degrees, and in quadrant 3, we go 180 degrees plus 60 degrees. So those two values will give me my values for theta. So this is going to be 120 degrees in quadrant 2 and 240 degrees in quadrant 3. So what you can do is, because this is an equation, right, to double check that your solutions are correct, I mean, you could just go cosine of 120 degrees and then go cosine of 240 degrees. And when you do that, what you will see is you get negative 0.5, right? So both of them are correct, okay? 120 works and 240 degrees work. Those are your values of theta. So you can just say theta equals 120 degrees, comma, 240 degrees. And there are your solutions, okay? And that's basically, in a nutshell, what we are going to be discussing today. Okay, questions like that, obviously, again, as with anything, they get a little more complicated as we work our way through the lesson, but that is the basic idea of what we are doing today. All right, next question. Now, in the next question, they start with something that's actually really important, okay? They say sine of theta all squared can be also written as sine squared of theta. So those two expressions are equivalent, okay? So when I have sine of theta, which is all squared, that's the same thing as sine squared of theta. So that leads me to the question here, which says sine squared of theta equals 0.5. And again, when I take a look at my domain, they're giving me all four quadrants, okay? So no quadrants are out of play here. They're saying I can look in quadrants 1, 2, 3, and 4. So what I'm going to do is I'm going to do the same basic steps that we did in the last question. So I'm going to go like this, okay? I'm going to say sine squared of theta equals 0.5, which again is exactly what they gave me in the question. Now, in the write-up of the question, the first thing I highlighted, they said, well, that's the same thing as saying sine of theta all squared, isn't it? Now, why is that important? Well, because that tells me basically how I can solve for 0.5. I'm going to take the square root of both sides. So when I take the square root of sine of theta all squared, I end up with sine of theta. Well, that's what I want. Now, on the other side, that means I'm going to have plus or minus. Okay, so we have positive and negative solutions. Okay, when we take the square root of a value, so I have plus or minus the square root of 0.5. Now, what does that mean to you? Well, when I take a look at the value of the sine ratio, okay, and I always ask you, well, is it positive or is it negative? Well, in this case, it's both, isn't it? So therefore, that means I'm looking in quadrants 1 and 2, okay, where sine is positive, but I also have to look in quadrants 3 and 4 because I'm going to have negative root of 0.5. So these two, okay, I have to look because it's a positive ratio, and these two because it's a negative. Now, normally you won't have a positive and a negative case. You will sometimes, like we see in this example. Most of the times it's either a positive or a negative, so you're looking in two quadrants, but in this case, okay, I have to find all four. So now I know the quadrants I'm looking in, 1, 2, 3, and 4. The step after that is always to determine what your reference angle is. So again, what am I going to do? I'm going to go second function sine of the square root of 0.5. Okay, and when you do that, again, we are in degrees. So again, make sure my calculator is in degree mode. It should be from the last question. My reference angle is 45 degrees. Okay, now I'm going to take that reference angle into all of my, in this case, 4 quadrants to determine the solutions. So I'm just going to write down Q1, Q2, Q3, Q4 for all the quadrants. Now in quadrant 1, we like quadrant 1 because the reference angle and rotation angles are the same. So 45 degrees is going to be an answer in quadrant 1. In quadrant 2, you're going to go 180 degrees minus the 45 degrees. That's 135 degrees. In quadrant 3, 180 degrees plus the 45 degrees. That's 225 degrees. And then in quadrant 4, 360 degrees minus 45 degrees. That leaves you with 315 degrees. So again, I'm talking about theta in this question. That is my variable or unknown. So theta equals 45 degrees, 135 degrees, 225 degrees, and 315 degrees. And there are your 4 solutions for this question. Okay, next page. Angle measure in degrees from the reciprocal ratios. So again, obviously the issue we're going to run into here is that we're talking about the reciprocal ratios, which are your secant, cosecant, and cotangent. Now you remember from the first day that I introduced that to you, we do not have a secant, cosecant, or cotangent button on our calculator. When I do those calculations, I must always do them in terms of sine, cosine, and tangent. So you'll see how I deal with that in this question. So again, they start by saying basically the same thing I just said. There are no calculator keys for cosecant, secant, or cotangent. So we have to rewrite those ratios, okay, in their primary form, meaning this. If I'm given cotangent of x being root 3, then I rewrite that as tan of x is 1 over root 3. And then from there, I can carry on and follow the same steps that I did in the last question. So that's what we're going to do here. Now, again, they're nice to us. They keep us in degree mode, okay, as we're learning. Okay, we will eventually get into radians, but this is degree mode. And again, they start out by saying cotangent of x is root 3. Well, if cotangent of x is root 3, just as they stated above, tan of x is going to be 1 over root 3. Okay, so then now I move on and follow the same steps that I did in the previous 2 examples. I take a look at my ratio, which is 1 over root 3. There is no negative sign in front of that, so that means that ratio is positive. Well, which quadrants is tangent positive in? It is positive in quadrant 1, okay, and think about the CAST, and in quadrant 3. So that's where I'm going to be looking for my solutions. The second step after I have the ratio and I've looked in the quadrants is to find my reference angle. So I'm going to go second function sine or tangent, second function tangent of 1 divided by the square root of 3, okay, and you get 30 degrees, okay? So your reference angle is 30 degrees. So again, very simply, I go into quadrant 1. We know in quadrant 1 the reference angle and the rotation angles are the same. So that'll leave me with 30 degrees. And in quadrant 3, we go 180 degrees plus our reference angle. So that will leave me with 210 degrees. So you'll see in this question, they're not saying theta, they're saying x. So I say x is equal to 30 degrees and 210 degrees. And there are my 2 solutions. Okay, so we're going to practice the same basic idea with the reciprocal ratios in the next 2 examples and see if it makes sense. All right, next, secant of x equals, and then they give me a value. Now again, they say to the nearest degree here. So again, always reading my instructions. Nearest degree means the nearest whole number. I am focused on my domain here, all 4 quadrants, 0 to 360, so nothing there that I need to be overly cautious about. So secant of x, well, secant of x is the reciprocal of cosine. So I'm going to go cosine is equal to 1 over negative 1.2631. Okay, so there's step 1. Now again, at this point, I don't know the exact value of that ratio, but what I do know, okay, is that this ratio is going to be negative, okay, because it's 1 divided by a negative number. That's going to give me a negative value, isn't it? So again, in your mind, you think about your cast rule and you say, all right, well, which quadrants is cosine negative in? Well, cosine is going to be negative in quadrants 2 and 3. Again, next step, find the reference angle. Okay, and again, please remember there is a negative here, but I don't use it when I go and find my reference angle. So I'm just going to go 1 divided by 1.2631, hit enter, and then second function cosine of that answer. And that gives you 37.655, etc. To the nearest degree, though, as they state in the instructions, that's 38 degrees. So there's going to be my reference angle. So I go into quadrant 2, and in quadrant 2 we go 180 minus the reference angle. So that will be 142 degrees. And then I go into quadrant 3, and in quadrant 3 it's 180 degrees plus 38 degrees, so that's 218 degrees. So there are your solutions. And again, we are dealing with the variable x here. So again, you would just say x is equal to 142 degrees and 218 degrees. And there are your two solutions. Okay. In B, I'm dealing with cosecant of x. Well, the reciprocal of cosecant is sine. So sine of x will equal 1 over 2.45. Okay, so there's the value of my ratio. Now again, no negative sign here. So we're dealing with where sine is positive. Sine is positive in quadrants 1 and 2. Step following that, determine your reference angle. So second function, sine, okay, of 1 divided by 2.45. So I'll actually go 1 divided by 2.45 first. Keep that whole value in my calculator. Second function, sine of the answer. And again, to the nearest whole degree, that is 24 degrees, which is my reference angle. In quadrant 1, we like quadrant 1 because our reference angle and rotation angles are the same. So 24 degrees in quadrant 1. Move to quadrant 2, and you go 180 degrees minus 24 degrees, which will give you a value of 156 degrees. Again, they're using the variable x here that we are solving for, so x will be equal to 24 degrees and 156 degrees. All right, moving right along. Determine the measure of theta to the nearest whole number, okay, where theta is between 0 degrees and 180 degrees. Now, what I'm going to do is just going to take a little break on the side here, and I'm going to show you what the graphs of sine and cosine look like, and you'll see why that's so important when we deal with questions like A and B here on the side. Okay, so I'm going to draw two graphs, and you're going to want to copy these down, and to some degree you're going to want to memorize what these graphs look like. Okay, so we'll start with sine of x up here, okay, and I will deal with cosine of x down here. Okay, so when I deal with sine of x, here's what sine of x looks like. Okay, it's this nice calming wave that looks like this. Okay, now the highest sine of x goes is 1, and the lowest it goes is -1. So that's its maximum and minimum value. It has values of 0, okay, or it is on the x-axis at these values. 0, okay, 180 degrees, which is basically pi in radians, and 360 degrees, which is 2 pi in radians. Okay, it hits its maximum value of 1, okay, right here at 90 degrees, and it hits its minimum value of -1, okay, right here at 270 degrees. So you can see what happens is that graph is basically cut into 4 quadrants, which are quadrants 1, 2, 3, and 4. And you can see, I'll label them here, this would be like quadrant 1, this would be like quadrant 2, this would be quadrant 3, and this is quadrant 4. Remember, sine is positive in 1 and 2, which you can see it is above the x-axis, and it's negative in 3 and 4 below the x-axis. But the point being is somebody asks you, where is sine of x equal to 0? Well, it's equal to 0 at 0, 180, and 360, right? Right where it's on the x-axis. If somebody asks you, where is sine equal to 1? Right there at 90 degrees. Where is sine equal to -1? Right there at 270 degrees. So you can do it algebraically like I was doing the previous questions, and I can show you that as well. But if you know what the graph of sine looks like I drew there, okay, those calculations are extremely fast and easy to come up with. Now, cosine of x has a very similar shape, but it doesn't start at where the x and the y-axis meet. It starts up here at a value of 1. Okay, so it has that same kind of calming, nice curve to it, like so. But it starts at a value of 1, and it also has a minimum of -1. But it hits the x-axis, or is equal to 0, okay, at 90 degrees and 270 degrees. Okay, so there's a difference. It is at 1 at 0 degrees, okay? It would be hitting -1 at 180 degrees, and then is back to a value of 1 at 360. But it follows the same basic ideas as sine does in terms of where is it positive and negative. So remember, cosine is positive in quadrants 1 and 4. Well, here's where it's positive, right there in 1 and 4. Okay, those two quadrants, it's negative in 2 and 3, which are down here below the x-axis. And again, if somebody asked you where does cosine equal 0, well, it equals 0 right there at 90 and right there at 270. If somebody asks you where does it equal negative 1, you could say, well, right there at 180 degrees. Okay, so knowing those two graphs helps a lot, and you'll see right here, because what's the first question? The first question is, where does cos of theta equal 0? Well, look at your graph. There are two places where the cosine graph equals 0. It equals 0 when theta is at 90 degrees and when it is at 270 degrees. So if I know the graph, boom, just like that, I know the solutions that they are looking for, okay? If I do not want to remember that graph, okay, and I want to do it algebraically, here's what you would do. You would come across this ratio and you'd say cos of theta equals 0, okay? Remember, my first step is always, is it positive or negative? Well, 0 is neither positive nor negative. So that means I have to look in all four quadrants. I'd have to look in quadrant 1, quadrant 2, quadrant 3, and quadrant 4. And then if you go and find your reference angle, so you'd go second function cosine of 0 degrees, you're going to find you get 90 degrees. Well, if I deal with that in quadrant 1, okay, remember quadrant 1, reference angle and rotation angle are the same, 90 degrees. Quadrant 2, what would you do? 180 minus 90. Well, that's 90 degrees. Go to quadrant 3, 180 plus 90, so that would give you 270. And then in quadrant 4, well, 360 minus 90, well, that's also 270, okay? So really, I only have two answers there, 90 degrees and 270, okay? Well, which when you look up here and I use the graph, those are the same two answers I got really quickly that way anyways, okay? So you don't have to remember the graph, but I'm promising you moving forward for the rest of this chapter and next chapter as well, knowing those graphs and those key critical points where the graph crosses the x-axis and where they have their max and min values really helps, okay? It's very important. So that same basic idea is really important in the next question because they're saying cosecant is undefined. Well, when something is undefined, okay, that means we tried to do what? We tried to divide by 0. That's what tried to happen. So that means with that cosecant ratio, it was something over 0. Okay, so that's how I know it's undefined. I tried to divide by 0. So therefore, that means the reciprocal, which would be sine of theta, would be 0 over, okay, anything. It doesn't matter, okay? I don't care what's in the denominator because what is 0 divided by anything? It is always 0. So as soon as I know cosecant of theta is undefined, I know automatically sine of theta is equal to 0. Well, again, all I need to do at this point is look at my graph and go, oh, where is sine equal to 0? Well, that's where it has its x-intercepts. So that would be where theta is 0, 180 degrees, okay, and 360 degrees. So again, I just know the graph, I know what it looks like, and I can find those values extremely quickly, okay? But I would put stars beside questions like this, okay? You will see them quite often. And again, the idea is that if you know those graphs, you can answer them extremely quickly. Okay, again, in B, I could solve that one algebraically the same way I did A. I would go sine of theta equals 0, okay? It's neither positive nor negative, so I'd have to look in all four quadrants, find my reference angle, which is 0, and you would see that 0, 180, and 360 are the values which are calculated using our calculation rules and expressions for each quadrant. Okay, next. So moving along, absolutely nothing different here in the last couple pages, except for we are now going to be doing the exact same thing, but in radian measure. Okay, so again, when they give me the value of a ratio, I don't care if it's positive or negative. That's just going to tell me which quadrant I'm looking for my solutions in. I find which quadrant I'm in, find the reference angle, find the rotation angles, and I am done. Okay, so they just take us through here what those expressions for reference angles and rotation angles are in the four quadrants, but using radian measure as opposed to degrees. So I jump to the questions, and the same thing. It says, in each case, determine the values of theta to the nearest hundredth, okay, so 2 decimal places, and they even say radian. Now, they don't have to say that because when you look at the domains here, what do you notice? The domains are now in radians, okay? And the one in B that I'm circling here, you have to be extremely careful of because it's only 0 to pi, which is like 0 to 180, which means you're only concerned with quadrants 1 and 2. In A, okay, which is obviously the one I'm going to start with, they're saying 0 to 2 pi, which is like 0 to 360, meaning all 4 quadrants are in play. So because I want nearest hundredth of a radian, okay, decimals, that means I can use my calculator, but again, I want to check to make sure that I am in the correct mode. So I go mode, I now go down to radian, hit enter so that my calculator is now going to do my trig calculations in radian measure. So A, cos of theta is equal to negative 0.5. I'm dealing with cosine and a negative ratio. So when I talk about cosine and it's negative, that means you are looking in quadrants 2 and 3. Then I find the reference angle. Okay, it's going to look a little different this time. So you're going to go second function cosine of 0.5. Okay, not the negative again. And as a reference, you get 1.047, etc. Okay, again, I don't round at this point. I'm going to round at the end of the question. So I go into quadrant 2. Okay, and what's the expression in quadrant 2? Well, in quadrant 2, in degrees, it would be 180 degrees minus the reference angle. So in quadrant 2 in radians, it's going to be pi minus your reference angle, so the 1.047, etc. And when I go into quadrant 3, which is normally 180 degrees plus, it's going to be pi plus your reference angle. Okay, so same expressions, just radian measure versus degree measure. Okay, so what that means is that theta, okay, that's my variable in this question, is equal to, and you're going to go pi minus your answer, okay, and to the nearest hundredth, 2 decimal places, you're going to get 2.09 radians for quadrant 2, and then in quadrant 3, you're going to go pi plus, okay, and that gives you a calculation of 4.19. So there are your two values in radian measure. Okay. In B, okay, again, like I said, a couple issues, cotangent, so that's a reciprocal ratio, and, okay, this restricted domain. So first thing is, I'm going to change this to tangent, or rewrite it in terms of tangent. So tangent will equal, again, I keep the negative sign, but it's going to be 1 over 5 over 4, which gives you 4 over 5. So now we're in business, okay, the value of tangent is negative, so that means normally I would be looking where tangent is negative in quadrants 2 and 4, okay? But because of this restricted domain, I do not need or even look for that solution of theta or value of theta in quadrant 4. I only care about quadrant 2 at this point. So same steps, I'm going to find the reference angle now that I know I'm in quadrant 2. So I'm going to go second function tangent of 4 over 5, okay? And you're going to get 0.6747, okay, etc. Again, I will round at the end of the question. So I go into quadrant 2, okay, and the expression in quadrant 2 is pi minus your reference angle. So that's 6747. So pi minus my reference angle, and I will get a value equal to 2.47. And there's your value for theta. So theta is equal to 2.47 radians, okay? And that's what it looks like in radian measure. Okay, now those questions are not bad, okay? They're pretty easy. What's going to happen is, and the majority of questions you're actually going to see are these questions on this next page, which are multiples of pi radians. So basically, they're going to ask you for exact values in radians, okay? So this is where we're going to be dealing with expressions that have pi in them. For example, 2 pi over 3, 4 pi over 3, okay? Things like that. So they walk us through an example here, okay? But again, I'm just going to, and you'll see this makes sense, but I'm going to walk you through each of these questions, and you're going to see that I'm doing the exact same thing I've done in the previous questions, okay? And I will tell you exactly what I'm doing, why I'm doing them, okay, and how we get them. If you want to fill in these values for your notes, okay, this has a value of 2 pi over 3 here, and 4 pi over 3 again. We just need to be good at adding fractions, and then we're good from there. All right, here we go. In each case, and again, here's that expression, determine the exact values of theta. And again, here's my interval, 0 to 2 pi, so nothing tricky there. I'm looking in all 4 quadrants. Okay, so first one, sine of theta is equal to 1/2. So again, I look at that ratio. We're dealing with sine, a primary ratio. That's great. And the value of the ratio is positive. So that means I'm looking in quadrants 1 and 2. Okay, nothing crazy there. So now I have to find the reference angle. So this is where a lot of people will start to kind of think in their minds in degrees or calculate in degrees and then convert to radians, however you want to think of it. So let's say that I put my mode for my calculator in degrees. Now I know that we are looking for the answer in radians, but just stick with me here. If I go second function sine of 0.5, which is 1/2, you get 30 degrees. Now, I'm just going to write that here, 30 degrees. Now, I know my answer has to be in radians, but what is 30 degrees in radians? That's pi over 6. Now, how do I know that so quickly? Well, remember, pi is equivalent to 180, isn't it? So it's like 180 divided by 6, which is 30. So pi over 6 radians is equivalent to 30 degrees. So my reference angle is pi over 6. So what I do is I go into quadrant 1. Well, again, we love quadrant 1 because our reference and rotation angles are the same. So there's my answer in quadrant 1, pi over 6. In quadrant 2, what do? We go pi or 180 minus the reference angle. So I have to go pi minus pi over 6. Well, when I do that calculation, I need a common denominator, don't I? So pi becomes 6 pi over 6 minus pi over 6, which is 5 pi over 6. So pi over 6 is your angle in quadrant 1, and 5 pi over 6 is your solution in quadrant 2. Okay, and those are your values of theta. In this question, that's the variable they are using. Okay, so that's how we do it. In B, okay, again, same thing here. Secant of theta, we don't like secant because we have to deal with the primary ratio. So that's going to be cos of theta equals negative, and then 1 over root 2. Okay, so again, because cosine is negative, that would mean I'm looking in quadrants 2 and 3. Okay, next step is let's find the reference angle. So again, if you want to think in degrees and then convert to radians, that's great. So you're going to go 1 divided by the square root of 2. Okay, and then, okay, what we can do is, again, double check your answer in degree mode. So 1 divided by the square root of 2, second function cosine of the answer, and you get 45 degrees. Now, 45 degrees is great, but it has to be in radians. That's 180 divided by 4. So 180 divided by 4. So in radian measure, 45 degrees is pi over 4 radians. That's my reference angle. So I go into quadrant 2, and in quadrant 2, we always go pi minus the reference angle. And in quadrant 3, we're going to go pi plus the reference angle. Okay, so this is going to be 4 pi over 4 minus pi over 4. So 3 pi over 4 will be your angle in quadrant 2. And in quadrant 3, it'll be 4 pi over 4 plus pi over 4, which is 5 pi over 4. Okay, so those are your 2 values of theta. Again, that's the variable they're using in this question. So theta would equal 3 pi over 4 and 5 pi over 4. Okay, the third and final question for today, and we've seen this before, cosecant of theta is undefined. What does that mean? Well, that automatically means that sine of theta equals 0. Okay, again, remember, when something's undefined, that means they tried to divide by 0. So therefore, the reciprocal of that sign means 0 is in the numerator. 0 divided by anything is 0. So sine of theta is 0. So this is one of those questions which, you know, if you remember the graph of sine, quite easy. So here's the graph of sine again. Okay, where does sine equal 0? Well, that's 0, 180 degrees, and 360 degrees. Well, those values in radians would be 0 degrees is 0 radians, 180 degrees is pi radians, and 360 degrees is 2 pi radian. And there are your 3 solutions for theta. Okay, so that's the lesson today. So pretty important day in terms of understanding what we did there. Again, practice it. You'll see that as you progress through the questions, you'll become, more comfortable with what we're doing. But as I stated at the beginning of the lesson, anytime you're in trouble or you're having difficulty with the questions, email me with a pic of the question, okay, what it is that you're struggling with, and I'll get back to you with, again, some write-up calculations on the question and, some text basically describing what to do and why you're doing it. And hopefully that will clear things up for you. So I hope you